Rita, come on in.
Hi.
Hi, watch out for all the wires.
Yeah.
And have you ever seen a television program like that?
So big? What is that?
Well, that's the second hand of a pocket watch.
Just the second hand?
Yes, that's the second hand. Of course, it looks like a
Yeah.
great big dial here on the television screen. And later on, you'll see how we're going to set that up, because today you and I are going to look at the world from, well, you could say 10 or 20 times, and even up to 100 times, and see a fascinating new world that you've never seen before, and it's right under your eyes all the time. And I'm also going to give you a series of mysteries to solve.
Mysteries?
Yes.
Oh, I like solving mysteries.
And you're going to have to solve them with the help of this
myself.
setup over here. Let me give you the first problem. It's not a particularly difficult one, I don't think. By the way, here are the things we're going to look at. You see, and they're plain, ordinary, everyday things.
Mystery in them?
And there are some mysteries in them, too. Now, we are going to look at them through a special microscope setup that I've rigged up. But everything that we're going to look at today, you can see with an ordinary magnifying glass, especially one that's small.
Yes.
So that you can magnify a lot of times. This one is a 5 and 10 times magnifier, and you can simply hold at it and, look at things. If you wear glasses, you put this over the rim of the glass, and you can hold it up like that.
It hooks on.
Yeah, it hooks on. And if you want to use this kind,
It goes around your head.
you see, and you look like this, and you put it up here and look like a unicorn. And there's actually another element that goes on the front, so you can magnify even more. So remember, everything that we are looking at today, if you have a magnifying glass, you can see them yourself at home by just going around looking at them. Let's give you the first problem. If I can pick it up.
A needle.
Yes, a needle. Well, the problem that I want you to try to solve is how long is the eye of the needle?
The eye.
Just the eye.
I can barely see it. that big.
Yes.
Itty bitty small.
Very, very small. But using the microscope, of course, we should be able to examine it and see what the eye of the needle is. And here's what I've done. I've taken a ruler and I've put a needle right there. See, I bent it so it wouldn't roll. And there's the eye. You're lying right along these little marks. Each one of these little marks is a 1/16 of an inch. This side is inches. Over on this side is centimeters, and we're going to use them later. So let's take a look at this needle, which I have already on this ruler, put it under the microscope, and see if you can measure the eye of the needle. Now, come over here first, though. I want to show you how all this works so that you'll understand what I'm doing. I put the ruler down like this, you see. Now this part here, down below here, is where I can do the focusing. See, by moving that,
goes up and down.
that goes up and down. So you're moving the specimen up and down. The light shining down here from all sides lights up the area here. And the image then goes up here and hits a prism and goes in through the optics of this microscope. And the engineers and scientists at Bosch and Lamb helped rig this up, and it works very, very well, because ordinarily you look straight down this way of the microscope, and of course we want it to go this way, so they helped make that prism. Then it goes through the optics of the microscope, and this is a stereo microscope that zooms, so you can zoom in and make things bigger. And we now are projecting the image onto the picture tube in the television camera.
It looks complicated.
Well,
it sounds easy, but it looks complicated.
It does
All
look
these
a little
wires and
complicated,
stuff.
but it's not really as complicated as looks. The image that we are throwing onto the image orthicon in here goes around through wires and comes back over here, and here it is on the television screen.
This is what I see.
So
You can
that's
see it
what
over there.
we can both, you see, talk about it and point to it. And remember, everything we see on here now, you can see with a magnifying glass. Now you see the ruler's out of position.
Yes.
So I have a little monitor over here that I can watch too.
Yeah.
There you see the needle.
There it is.
Okay, now I'll run the platform down, or up, I'm sorry, until because I had it focused on the watch, you see, and the watch was thicker.
Yeah, there it is. Makes
Now.
two of them.
Yeah, now each one of these is a 1/16 of an inch. 1/16 of an inch, see? There's the eye of the needle. Now, I told you this is zoom up, so I'll zoom up just a little bit so you can see it a little more clearly.
Yes.
Okay, now looking at the eye of the needle, if this is a 1/16 of an inch, how long do you say the eye of the needle is about?
About half a 16th.
Which is about a 32nd.
36 is pretty small.
1/32 of an inch. And you can see that if you had a finer ruler, you could divide this all up into little squares, and you could
really
even measure
divide
the
it.
width and the length and the whole thing. Well, that was relatively easy, wasn't it?
Yeah. Look at how big the needle is in here. It's really tiny.
While we've got this ruler, remember I said the other side had centimeters on it?
Yes.
Let's see if we can use it to figure out how much we're magnifying. I'll simply move the ruler over till we get to the Each one of these little lines here is a millimeter. Now, I'll go back down to the low position on the zoom, and I'll line it right up with the 9 on this side, see?
Right.
About like that.
9.
Now, I measured this television tube here before and found that it was 500 millimeters. 500 of these little marks
500.
in reality, you see. Now we're looking at how many? There's 5, 10, 15,
Not
very
20.
close to 20. So if we now take 20 millimeters and enlarge them so that it goes up to 500, you
And
simply
divide 20 into 500,
Yeah.
which is half of 50 is 25.
25
So-
times. So we're enlarging this
This is a lot.
25 times. Now, however, when I zoom up, watch. I'll position the ruler a little bit.
The 8 is pretty big.
Getting pretty big, and every time I move here, of course, you can see it jiggle around. I'll bring it into focus a little better. Well, it's
This is
now.
just one
Yeah,
room,
now we
right?
have 1,
2,
2, 3, 4, and 5
About
with this other
5.
little piece over
Yeah.
here. So now we have 5 millimeters filling
Into
a
500.
500 millimeter screen. So how much
So
that?
that'd be 100.
100.
100 times.
Yeah.
Oh, boy.
So when we look at things now, we're going to start at about 25 and go up to 100. Okay? Now you remember
really
that?
magnifying it.
You remember that watch that I
Yes.
had here when you first came in, and I had it focused down there on the second hand. But you know that the minute hand moves too, don't you?
Yes, every time the second hand goes around 60 seconds, and the minute hand
Goes
around
one little
Yes.
little bump there.
Right.
Well, let's put that under the microscope and see if you can actually see the minute hand. Now, see, there's the second hand. Now we're looking at the minute hand down there.
That's right.
All right, now take a close look at it. Now I'll zoom up a little bit on it. Watch.
Yes, it moves very, very slowly. When you even look at it, it doesn't even move.
All right, now watch. See it?
It's moving. It's constantly moving, though. It
Yeah.
doesn't... I thought that it waited a minute, then it went a minute.
Oh, I see.
It goes so
Well, now
slowly.
this shouldn't be so surprising because, after all, this is connected to a gear, isn't it?
Yeah.
And the gear
Yeah,
has a series of
we
little
saw
teeth
that
in it.
once.
And so that at each time a gear, moves one more tooth, why it's moving the handle of it. And there you can see the
One
actual.
time I just stared at a clock, and it looked like it never went there, and then all of a sudden it's at the next notch here.
Well, there may be a different system in the clock that you looked at. Anyway, how come we can see it when we magnify it here?
Yeah, it's moving pretty fast.
I'll move it
I
down.
guess you magnified everything, and the motion also.
Well, why would that be? How can you magnify motion?
Well, when you magnified this piece here, this will cover at the
Yeah,
same time.
right.
So,
So
magnify that. magnify
So
this.
when you magnify distance, and if a certain object takes a
Look
certain
at it
time to
going
go through a
fast.
certain distance, well, you magnify the speed too. And you must remember this when you look at through the magnifying glass or the microscope at animals too. When they swim or do something, well, you must remember that you're magnifying their
It must be
movement
pretty fast.
as well.
It's
There it
already
is.
in the next notch.
So
It's
there's probably the
fast
first
there.
time you've actually seen the minute hand of a. There's
There's a
second
second
hand
going around.
over there. Well, now these two problems were not particularly difficult, but this time I have an engineering problem for you.
Engineering.
Yes, you've seen these little chains, haven't you?
Yeah, keychain.
It's a keychain.
Keys on it.
Well, I want you to figure out
So
how to
hard
make.
about that.
I want you to figure out how to make it.
How to make it.
Yes. In other words, you have to have something very strong yet quite flexible. And you know these are little beads, and in between each little bead is a wire.
To get a bead on the wire?
Yes, you have to get the bead between two balls. I have to get a wire between two balls. Now imagine this, there's a little length of wire, and on the end of the length of wire is a little ball.
Yeah.
That ball is bigger than the hole that goes in the little ball in the sphere. So somehow you got to get that
Get the-
big thing through the hole in the sphere.
Well, why don't they just get the ball and put it on top of everything? Like here's they have
Yeah.
the ball, but it couldn't be closed because they never get it
Yes.
on. Have to be open, and then they put it over everything, and then somehow they either heat it or glue it and somehow to
Let's-
stick it on.
Let's put it under the microscope and see if you can figure
Aha,
out.
let's find out.
See if you can
Open
figure
that.
out from.
It
From-
sounds good. That's how they
It's
do it.
yes, it sounds like a very good theory. Let's put it on and see.
There it is. It was
Well,
big.
let's go down to the low magnification first and see if you can see. What do you see?
Here, it's split in half.
Hmm?
It's split in half.
Yes.
And there.
Yes.
So I guess I was right.
So you guess you were right. Let's take a look at one of them at higher magnification. Now, see it?
They must have brought it together and then somehow get it to stick together.
Well, what they do is they have these little pieces of wire, you know, with the little balls we talked
Yeah.
about, and the spheres are simply open like this, and as they go through a machine automatically just closes them, and, you know, this way.
It'd take a long time to do it, wouldn't it?
Well,
By the time they get it over and...
As a matter of fact, I've never seen the machine, but Dr. Seamus was telling me about that. He went through a factory one time, and the chain just rolls out, and they roll it up as fast as they can go. So the machine, you know, is closing them faster than you
I
can
forgot
possibly see.
machines are fascinating.
But congratulations, you were right. You figured out how to do
How
it.
do you like that?
An engineering problem which you were able to solve. Well, now that's a common everyday object that was kind of fun to look at. Here's another one. If you do this at home, you'll have to be careful because you may cut yourself. But here's
I
a
wouldn't do that.
here's a 100-watt light bulb, and you put a file down the bottom and file a couple of notches, and then if you wrap it lightly where you can open it, you can take the envelope, you know, the glass thing off. And what I want you to do is to take a look at the filament.
Yeah, well, it's just like a coil, one end to the other.
Can
It
you
heats
imagine
up.
making such a little coil?
Oh, yeah, they'll have to have a machine that spins it around.
It
turns
does something
around.
like that. Yeah. Except when you look at the coil of the filament of that's a 100-watt light bulb, under the microscope or under the magnifying glass, you will be surprised because you will see something that you never really imagined. If you thought that coil was difficult, wait till you look at it under the microscope. And I'm going to later on plug it in and turn it on so we can actually see it glowing. So I'll put it here in my plug.
magnified, so you glow?
Yeah, and we'll turn it on. You'll see what happens when you turn on a light bulb.
All right. Just looks like a coil from one
Yes,
to the
all
other.
right.
It must be pretty hard to make it. The machine that'd have to go round and round and round.
Now, this time I have a little clamp here that I'll clamp the filament in so I can turn it around and
There it is.
we'll see it that way. Okay, now, there it is, slightly out of focus. I'll bring it down and now I'll get it over there to the
This looks
edge. You
like
see
it.
where it's attached?
Yes, it's attached onto there.
Yeah, it looks like a coil, just you thought,
Yeah,
right?
like I said,
All right.
round.
But now I will zoom up on it, and I think you will be surprised. Watch. I gotta move it over. Now I'll
It's a coil.
reposition the lights a little bit to get some more light on it. And now, look.
Holy cow! Look, it's all turned around, coiled on a coil.
Yes. In other words, first they coiled it, and then they coiled it again.
Oh boy, how'd they do that?
Well, I don't know. This is a very complex machine with all kinds of, you know, big
They'd
big
have to be
gears and things.
coiling it and then coil it around the coil.
And
Oh,
of course,
boy, that's
this
pretty hard,
is
isn't it?
probably done while it's hot, because this is made of tungsten, which doesn't, you know, bend too easily. And so they coiled the coil while it was hot, and then coiled it first time, and then the second time while it was hot, and then let it cool. And of course, it's fastened to the things over
Never
here.
knew there was a coil in the coil.
Well, now let's try lighting it. I'll go back down to the low magnification again, and center it.
Coil in a coil.
Okay, now I'll turn down some of the lights a little bit, and now I'll slowly bring the current up, and you watch what happens to the filament of a light bulb. See it?
Red hot, yes.
Yes, it got very hot. I'll turn some of the other lights off so we can see a little better now. See how it's glowing?
Yes.
Now it's getting
Very
red.
hot.
Now let's zoom up on it just a bit, right in that section there.
It's very hot.
Notice,
Very light.
I'll blow on it. You'll watch it cool off. Watch. See it?
Yes, it cools up and it gets very hot.
Okay, watch that
It's,
section.
it's turning.
Look how it's.
Woo. Look at it, it's twisting. Ooh, it's off.
Yeah,
Broke off.
it broke off. In fact, the
Gee,
bulb,
I never saw that before.
the bulb is now burned out.
Yeah, that's
And when you look at it through your magnifying glass, you can sometimes see that there's a break in the filament. Now, if you try to do this at home, by just looking through the glass, don't forget that this would not happen because ordinarily there's not air around it. And I took
Yeah.
the glass away so there was air here, so
More
the tungsten
air.
can burn quickly.
Yeah.
So,
it
there's
heated up, expanded, and then
Twisted.
It just started to twist and
and
broke
finally
off.
broke off. Yes.
You know, sometimes when you shake it, you can hear a little piece of it.
Yes, well, you see, if it broke, it happened to break in two pieces, one of these might fall down, you see.
If it
and
doesn't like it.
then you shake it, and that's what
bulb.
you're listening to when you shake the bulb, part of the broken filament, probably.
So you can see there's each one is around the coil.
Well, now, this is an ordinary piece of engineering problem, and a very difficult one, but one that you're quite accustomed to. Here's one that you've probably never seen before, which is, I think, even more marvelous in a way. This little...
What is it?
Well, that little thing that's, about the third of the size of a lump of sugar is a complete electrical circuit.
Complete electrical. That little thing there?
Yes, it's a special kind of circuit called a flip-flop circuit, and in it are a couple of transistors and two very small tube-like devices. You know, a radio tube that has glass around it, yes. They're called diodes, and there are two of them in there, and they're enclosed in glass.
Where?
Well,
Where?
right down in there. And the women, it's usually women who make these, work in a big room, and it's all as clean as they can possibly get. Everybody wears white uniforms, and they have to dust all their clothes off before they come in and wear special uniforms, and they work under microscopes just like this one over here.
Well, I guess they couldn't do it if it's so tiny.
No,
you can see it.
because what they have to do, of course, is to put those little things into position. And doing that, of course, would mean that they would have to magnify it, and that's exactly what this microscope is used for in industry. There's my big thumb.
Pretty big.
Now, let me see if I can get it under there so we can take a look at it. There's the edge of it. Those wires ordinarily stick up, and I bent them out of the way so that we could look at it, you see. Now, there's this is called a module, meaning a little section.
The whole part?
This is the whole thing is a module. There are the two transistors, and here are the wires which they have to solder in. Now, let's see. You see that old thing over there?
It's so tiny.
Yeah, well, let me move it over to the center of the magnifier and zoom up on it, and you see if you can...
Hey, looks like there are two switches or cords that stuck together.
Now, let me see if I can check the focus. There, do you see what I see?
Like a bubble over the glass.
Yes.
You know the cord that you plug in, they look like they're plugged together.
These two, this is a wire coming down here that they put a little bump on, you see, and this is another wire coming here with a little bump on it, and between here are the semiconductor kind of parts. And after they put them through, evidently, a hole in the glass tube, and then they melt the whole thing so it encompasses it, and there's an actual little... It's not really...
It's so tiny.
You shouldn't really call it a tube, because although it's certainly enclosed in glass, it's something like a transistor. But imagine now...
So tiny. How could they ever do it?
Well, it does...
I guess they do have the microscopes.
Yes, they certainly need microscopes. And this one happens to be a reject. In other words, somebody also inspected this to see whether there was anything wrong with it. And of
How
course
do they find out?
They have to look under a microscope again and
After
check
all
it.
that work of finally getting it, and somebody rejects
After they
it.
put them all together, if something happens to them, they simply just throw out the whole thing. They don't try to repair it, you know, because it's easier to take it.
Yeah, I guess it's so.
Anyway, this is the sort of thing that would be used in a computer or in a outer space computer, you know, that would be on board a spaceship. And
so tiny, we said
something
so
you've
big.
never seen before.
No, I never thought I'd
Imagine
that.
the marvel of modern engineering to be able to put that thing together.
Who could even think of that, putting those little two things together?
Well, now here, the next problem I have for you is one that is usually posed in mystery stories. So you're going to be a detective.
Aha, Sherlock Holmes.
Yes. You know how when the ransom note is sent and or type, you know, they can look at the type and find out what typewriter it was written on?
Yeah, as though it said, this typewriter is...
Well, here are three alphabets, you see, typed A through Z. And two of these alphabets were typed on the same typewriter. And one was typed on a different typewriter.
Oh, I
So
see.
all you have to do is match up the two lines that were typed on the same typewriter.
I need my magnifying glass.
Yes, you certainly do. We'll put it under the microscope. And what are you going to look for?
Well, I guess there's some flaw or mistake in a word, in the letter. It said,
Well, this seems surprising because
It wouldn't say, you know.
No.
Wouldn't tell you.
But each one of this is exactly the same kind of type. In other words, it came out of the same mold. But as the typewriter is used, or perhaps as they pull it out, or as somebody put it in, little chips or little sections of the thing change, and that's what you're going to have to look for.
Pretty careful. I have to be
All
careful
right,
to find it.
Let's try it.
I
Let's
don't know
see.
if I can do it.
Well,
I hope so.
I'll stay up at high magnification first,
They all look the same.
so that you can see all three letters, all three lines at once. Okay, now. Two of these lines are the same. One is different. Look at the
See
C.
these two C's?
Yes.
There's not too much in between. Not much. And look at the C. It has a line in it. Right
So far you'd say these two are the same?
I'd say these two are the same. Look at the C. They look
Yeah.
alike, but that has a...
Okay, well
Mistake
now
right
you don't
there,
want
line
to jump
right
to
across it.
conclusion. You think the bottom two are the same so far. I'll move it over a little bit and you check some other letters.
The H. Here's one. See there's like a dot on the H's.
Yes.
In there too.
Yes.
There isn't any there.
Check the eyes.
I?
Mm-hmm.
Oh.
Well?
The eye. Look at this one. It looks like thick, and the dot is like resting on it.
Yes.
Very
And this
thick.
one?
Oh, that looks thin.
And this one?
Oh, that looks like that.
Well, now let's look at these in high
Which one?
Let's look at high magnification. We'll go up and look at this one first to check your results and see if you now will agree with your preliminary investigation. There's the eye. All right. Now,
Pretty big dot.
it's a big dot, and notice it's flush here. That's touching.
Yes, and here it's pretty big.
And also there's some bumps along in here. You see
Yeah.
that? Okay. Now that's
Keep
the
it in my mind.
one on the top one. Now here comes the middle one.
Oh, gee, it's different.
It's different, isn't it?
Yeah. See here how thin it is,
Yeah.
and the dot too.
You can almost see
Yeah.
through the dot, can't you? All right. Now check the bottom one. Those two are obviously different.
And that looks like the first one.
That looks like the first one.
But how could it be that? I guess my first one was wrong.
Well,
Don't jump to
you see,
conclusions.
yeah, as a detective or the scientist in the scientific laboratory at the detective headquarters would look at many letters. He wouldn't just look at one or two. In fact, I'll move it down over here and you can look at some of the others now. See if you would agree that. How about the T's? The top and bottom T look like they're the
Yeah,
same?
these two look like they're the
Yes.
same.
But
See, more
the
here.
S's, you know, you'd kind of doubt, so that you'd certainly go to find those letters. How about the R's? Well, that's not so hard.
These two.
Yeah. But,
I think there.
yes, but so that therefore you'd have to examine many letters before you made up your mind, and actually it was the top and bottom.
It was.
Yes, it was the top and bottom.
Wow.
So
I was right.
but that's how they do it,
Last
you
one.
see, by very carefully examining under the microscope the differences, in very small differences in the letters.
I should have been careful in the beginning.
All right,
not said it.
now, besides investigating things like that, you could also investigate things in the plant and animal world. You know what that is?
Gone. Yeah, they call it a burdock.
Yeah. Okay, now take it off. Feel how it sticks?
Take it up.
Let it hang there one.
It's just-
How come do you suppose that seed can stick to your finger and to your wool skirt?
Well, I guess there's some sticky substance. Wouldn't be glue. I guess something sticky in itself.
That would make sense, wouldn't it?
Yeah.
All
Stick
right.
on. How else could it ever
All right,
do it?
let's put it under the microscope and see if you can see what it is that makes burr stick.
Probably of itself.
Like,
it
if I
has
can get it
some
off my
sticky-
fingers.
Yeah.
Let's see if I can find a good section. Now I'll turn the lights up from underneath so we get a little more of a... You see what I see?
Oh no, they're hooks.
Yes, they're little hooks.
It looks like a hook.
In
They're
fact,
hooked onto me.
now I'll go up a little more so we can see it a little better. And
Oh,
I'll
that one's very
I'll have to
good.
refocus on... There's one right in the center, see it?
Yeah, this one here.
Okay, now how does a burr stick to you?
Well, it has hooks on it.
Yes, it has
To your
hooks.
finger? What does
They-
it do? Hooks onto
Yeah,
your
they hook
finger?
onto little sections of your skin, not enough
My
to hurt,
brisket.
not enough to hurt you. But what do you suppose it does to the wool?
Probably takes it along with it.
Yeah, well now you look right.
Hangs on.
I'll move it down into the center of the screen there. I'll go up just a little more in magnification. Do you see what I see?
Oh, what's that? Oh no, that's my skirt.
That's part of your skirt. Sure. Here's a piece of wool that when you
Oh.
pulled it away from you, you of course took a piece of wool from your skirt
Well,
too.
once it hooks on, it's there.
It hangs on very well.
So that's how it hooks onto animals.
Yeah,
Isn't
so-
that how it's
Right,
supposed to
with a
go
cow's tail or fur and a dog's foot or something, why it hooks onto them, and then actually the
This
seed,
hooks.
let's go back down to lower magnification so you can see more of the seed. The actual seed is inside here and it dries open and later on the seeds come out, you see. So
Gee, that's pretty good in itself. It can find a way by hooking on.
now
Yeah,
there's
those hooks.
another thing that you should look at when you get out your magnifying glass is coins. And here is a new Lincoln head penny.
Well, what's mysterious about a coin?
Well, what's on the other side?
There's a building.
Yes.
Some kind of
Now, on some of the older ones, there's a sort of wreath, but on the new ones, you'll find a building. What building do you suppose it is? There's the
Well,
building.
I guess if Lincoln's here, Lincoln Memorial.
Well, let's see if we can prove it by putting it under the microscope and taking a look at that building.
Maybe it says it, Lincoln Memorial.
Yeah, maybe it says it. Well, here,
I was wrong on that one. Well, can't be good.
I got it
All
right
right.
side up. No, I have it upside down.
There it is.
Now I'll focus on it, and there is the building that you were talking about, you see?
It doesn't say it anyplace.
No, it doesn't say anything about it. But these are the columns. It looks something like the Lincoln Memorial. I'll zoom up just a little bit and see if you see what I see.
Oh, yeah. That's Lincoln.
Yes.
Lincoln inside there?
There's Lincoln.
Oh, yes, he sits down.
Sure,
and
he's
sitting there.
There, you can. I got a shadow on him, so you can see him. You see?
He's
Isn't
like
that
a bear.
fantastic? That inside the pillars of on the head of on the other side of the Lincoln head penny is another figure of Lincoln.
I never saw that. Hey, that's a good trick. I have a penny that has Lincoln on both sides.
And you can see this with an ordinary magnifying glass by simply putting it up to your eye, and you can see that there is a figure of Lincoln inside the Lincoln Memorial.
Oh, I never knew that.
So when you get out your magnifying glass, why you look at everything around the house.
Go
Look-
investigate
Yeah,
it,
you
see
put
what I can find.
put pills in water, look at flour and coffee
Mm.
and tea and all these things, and I think you'll find if you look at the world at 10 to 20 times, or if 100 if you have a microscope, well, you'll find a whole new fascinating world, and you'll learn a lot about it that you can't possibly in any other way, like the beaded chain, or like the head in the Lincoln Memorial. So if you multiply, let's check now, how much do we magnify here?
We
In low
magnified
magnifier?
25
25 times.
And then 100 times.
And up to 100 times. So you may have a little trouble magnifying it quite this big at home with your magnifying glass, but still take a look at it.
Yeah, I'll be there with my head on the
And
camera looking at everything.
what's the first one you're going to try?
Oh, I think the penny. I'm going to
penny.
show everybody
Okay,
that.
next time you get a Lincoln head penny, turn it over and see if you can see the figure of Lincoln inside the Lincoln Memorial.